Hey my friends, welcome back. Got a new project to do. Someone just sent me a condensing unit for a Northland refrigerator. They said that it had a freon leak and they can't get it fixed, and it's an R12 unit, and I just got it in the mail, so it's in this box here and it came apart. I haven't even opened it yet, but I'll have to fix that when I send it back. Okay, so Phillips head screwdriver. I'll get back to you as soon as I get this unpacked. Okay, now it's out. Now I can take it apart. I've worked on these units before in my day, and they were always difficult to work on. One of the nice things about Northland is that the whole tops came off and it was easier to deliver and install these units. Of course, GE also used to make built-in refrigerators that had a removable top. And that's just the way it is now. So anyway, this is a unit for, I'm sorry, I forgot the model number, but looking at the size of the compressor, I want to say that's probably either a quarter or a third. I'll check it out. Anyway, let's start to take this apart. Let me get a 1/4 inch nut driver here. Okay, let's take this thing apart. And this part of it you can do in the customer's home, but you most always have to pull these things out, and if you don't, it's really hard to get at anything. But when you're on a job somewhere, it's not always convenient to pull it out. Look how easy this is when it's on a bench. And that was the beauty of these units. They broke down. You could basically send it out and get it fixed. So we live and we learn. Yeah, there's some in the front here. It's been a while since I've taken, that's a 5/16, since I've taken this thing apart, this machine. Okay, what do we got here? Still got over there, okay. Okay. That's a 5/16. What is this? They couldn't use the same size bolts? Okay. There you go. All right. Taking this cover off is easy here in the shop. Not so easy in the customer's home. But you can replace the timer without pulling that cover off if you have small hands. And if you don't, you need long tools to get in there. So anyway, there's only one bolt holding this timer on. See? There's only one screw in there. That's it. Fortunately, they're all quick connects, so you can pull it apart. And your condenser fan motor is, I believe, it's got a bent blade. We'll take that out. I've changed these things in the field, and they're not easy. And once I had to fix somebody's unit that I just couldn't get back there, or the guy was really desperate for a repair. I wound up putting a Sub-Zero fan motor in here, but it's reverse rotation, this motor. If you can look at this shape of the blade, you'll see how it turns to scoop up air. Anyway, it took me a while to do it. I had to change the blade, I changed the motor and all that, and I got it to work. But it was a project. It was a long project. Wouldn't do it again. Anyway, we got this is a Danfoss. I'm not sure the numbers. I'll look it up. The serial number's right here. It says it's a model NR. Hold on a second. Even with glasses, I need a magnifying glass. All right, this says model number is N as in Nancy, M as in Mary, 18, H as in Harry. And it's 1/3 horsepower, 5.5 amps. Defrost is 4 amps. Single phase. All right, so that's a 1/3 horsepower motor. And let's see, R12, 8 ounces. All right, those are the specs. Next thing I'm going to do is plug it in. Okay, a little bit of a problem. I don't have the connectors for the controls to turn this thing on. So I'm going to have to figure out which wires are which so I can at least get it up and running. But in the meantime, since they've expected that this thing has a Freon leak, take this cover off here, we'll expose the evaporator. You know, if we're up to me, I think all refrigerators should be made like this. Just change the unit. You can do that in the field, swap out a unit, but you know, I only abide by the rules, I don't make them. There you go. Insulated cover. This is a piece of aluminum. Another cover. Let me get a light here. Alright, here is your evaporator fan motor. Here's your evaporator coil. I'm looking for signs of oil. Wouldn't that be something if they sent this to me and there's nothing wrong with it? I've had that happen. Boy, that fan is really close to that evaporator. Look at that. The shaft actually is touching the evaporator. Anyway, here's our limit switch, our defrost heater. I've changed this evaporator coil in the past. You can't do it in the house. Not when you can pull it into the shop. Anyway, let me try to get this thing up and running. Here's your process ports. And it doesn't look like it's been abused in any way. We'll figure out why you might be able to just jump these two wires out, turn on this compressor. Alright, let me figure this out and I'll come back. Okay, so here's one of my adapters I made for doing these kinds of jobs in my shop. I have several different connections. So let's plug it in. It's a direct right to the compressor and the condenser fan motor. The evaporator fan's not going to run and nothing else will, because this is just a direct compressor to run. Okay, it's up and running. Condenser fan motor is not turning because the blade, I believe, is hitting the condenser. See, it wants to turn. Okay, I'm going to pull this out and then we'll get back. I need a 1/4" nut driver. I'll get my amp probe also so I can check the run amps and my gauges. hook up my gauges. I just put an evaporator coil in this unit. This is the 4th evaporator coil I've replaced on a 424 in about a month's time, and all 4 times the upper evaporator is the one that leaks. The only one that didn't was a really old 424 that has the 3/8 all copper evaporator coils, which they don't make anymore, and they were not leaking at the joints, they were leaking inside the evaporator, and I picked it up with my ultrasound. Okay, I'm going to unplug this. I'm going to go get my amp probe, and we'll hook up the gauges. Okay, so this fan support bracket does come out, but you have to get to the back screws, and you can see how difficult this would be if you tried to do this in a customer's home without taking this whole unit out. I mean, it's difficult enough just to get to all this. There's one up here and there's another one on the bottom, which is a little easier to get to. The blade gets in the way. You know, I see a motor mount down here for a compressor. I'm just wondering, maybe this, oh yeah, I think this compressor was changed. It looks like that does not like factory work for me. You can see it down here. The rubber mount is missing. All right. Like I said, I've done this in the field before in my younger days. And let me tell you, it was a challenge. Just like it's a challenge to do it here in my shop. I'm gonna have to make a little bend here. Okay, goes in like that. Here's our condenser motor. I'm just gonna cut this. I mean, look at that blade. Holy smoke, if that could have happened in shipping, look, the condenser looks like it's been smashed in. Wow. We'll get a fin comb and straighten that out before we put this together. I'm sure this motor is good. And it is a, oh, get the magnifying glass out there. This is 2 watt, which I expected, clockwise, 0.19 amps, 1100 RPMs, made in the USA, GE. These are pretty similar to the ones we're still using today, the GE motors. This is the foot mounted. You don't see them often anymore, but they're also, you can mount them from the back too. All right, let me get to the next step. See that motor mount there, sitting there? Yeah. Okay, let's start this thing up. Check the amperage draw. That's a lot of amps. 7, 6. Look at the head pressure. It's almost 250. It's going up. Back pressure is about 7, 8 pounds. Yep. Head pressure still going up. It's restricted somewhere, and I think the customer mentioned something to me about that. Okay, let's get back to you. Okay, so back to this Northland. I remember I just talked to the customer because they told me that they had it checked by a local refrigeration company up where they were, which is upstate New York somewhere, and that they told them that the heat exchanger basically, or there was a restriction between the sealed system and the evaporator, capillary tube possibly, or something like that. But definitely a restriction, because you can see the head pressure as high as, I mean, almost, it was over 250. Back pressure's 40. So there should be some kind of equilibration taking place, which isn't happening. So what was the first thing you would do? Check. I think I would check the filter first. I can disconnect the capillary tube here and then see if we have flow through the condenser. So maybe this thing, I don't know how that could have possibly gotten damaged, but if one of these coils is damaged and blocked, we don't know. We have to open up the system. So before I do that, I have to get my recovery system out and recover the refrigerant, and we'll go from there. Okay. Okay, shut this down. We're down to 26-inch vacuum there. So we know we got everything out. Closing off our charging column. Let's see what we pulled out of here. Eight ounces right on the nose. Right there, you can see it. 8 ounces. Wow. So we don't have a leak. Appears we don't have a leak. Got to be some kind of restriction between the capillary tube. So the first thing we'll do is we'll cut this. Let me put this equipment away, get it out of the way. Okay. I want to point out a couple of things before I cut the system open. When the evaporator coil goes into defrost, there's a drain pan underneath the evaporator. It's a stainless steel drain pan. Let's see if you can see. Let me get over here. It's right, it goes out right there in the corner. Comes out right here at that nipple, and just overflows into the bottom, this tray. This is also either galvanized or stainless steel. It looks stainless steel. And you can see it's like a little drain pan. Now I see a loose bolt out there, and there's the missing motor mount. It looks like it might be broken off. That's easy to fix. We can get that out. All right, so let's open up. Okay, I'm just going to cut this right here in case I have to reuse it. I'll score that and open that up a little bit, and then we'll just heat this and pull out that capillary tube. Okay, make sure we can see that. Good. All right, now the next thing we do is pressurize it. Problem is, I think I'm almost out of nitrogen, so I might have to use compressed air. I do have a drying filter on there so it doesn't put any moisture in the system, but we're going to really evacuate this thing anyway before we recharge it, so I'm not overly concerned about moisture getting in because I'm going to take it out. Alright, so let me do that. Okay, so I removed the capillary tube from the filter dryer. Just took this whole thing right out. Let's see now if we can get some pressure flow in here. Nothing coming through there. That's strange. Alright, so now we'll unsweat it over here. I'll let that cool down, and then we'll check it, see why. We even cut it open and see if it's clogged, and if it is, maybe we could determine why. In the meantime, we need a functioning condenser fan motor, so I just feel like this whole condenser was smashed in some way. Don't know how. If this unit was dropped, maybe the compressor was forced forward, and that would be the reason why this little this bolt down here, that's part of the unit that must go over there. What I did here was started the compressor, pulling down to maybe 22 inches in the vacuum, but we've got flow through the condenser. So that's telling me the condenser is not blocked in any way. It's coming out of the compressor right there. There's a little bit of a really sharp bend. That's a little tight for a discharge line. Should be come out more. That's a restriction. Anyway, I think the compressor's pumping down. Now it's down to about 25. If this thing goes lower, then I would rule out the compressor being bad. So let's let the rest of that compressor suck out all the air that's in there. And then, okay, so I took the blade off to here. See if we can straighten that out. Okay, that's cool. I'm going to get a pipe cutter and open that up. Oh. Silica gel. That's not clogged. I can see a screen in there. Oh no, that's my screen. It's funny, I don't see any restrictions. I see the screen. Go figure, right? Go figure. It's not the strongest compressor. It should pull down more than that. That's like right on the boundary. Don't forget we had a high head pressure at 250. Okay, let me figure out what we're going to do here, and I'll get back to you. Okay, the more I'm thinking about this, the more I'm thinking that this unit was dropped, because this screw is not a screw, it's actually a pin. You can see the weld marks on the bottom, and they're not rusted or anything. So it must have recently happened. And the compressor pushed the condenser fan motor into the condenser, and that's why that blade was flattened out and crooked. So I'm not sure. See, I don't know if you can see that, but that was in there like that. It was tack welded on, and I think that recently broke. So I'm going to have to tell the owner that it was damaged in shipping, but that doesn't solve the problem of why wasn't it working. So what we're going to do now is we're going to fix this fan situation here and get the condenser fan motor to run. There's a good possibility that the problem could be in the compressor, which I doubt, although the compressor is, or was, pulling down to 26 inches in the vacuum. That's kind of like not terribly bad, but it should be 28, 29 on a domestic compressor like this. I mean, I've seen my gauge go down to 29 point something, but that's a gauge. It's not 100% accurate. It's got to get plus or minus a couple of degrees. Anyway, I think we could pull this compressor out, re-weld that in there, get this mounted right. Or, since this is a capacitor on here, this is a high torque compressor. I'm not sure if I have one of these around. I probably have one in one of my other shops. So anyway, let's going to play around with this, and I'll get back to you when I decide what I'm going to do. Okay, a couple of more things there. I've been pondering around with this, thinking about it, looking it over, and I concluded that this unit was dropped in shipment, because look at the box. That's the bottom. Look at the way they put that together. This thing was dropped because when I got it, that piece was loose. And look at this. The compressor, all the studs that hold the compressor in place have broken off. I thought just one, but they're all disconnected. You see the welds broke. This thing, and then what happened was the compressor was pushed forward, which pushed the condenser fan motor and the blade into the condenser. Okay, so this is fixable. This is fixable. I already worked on this already. I got this to spin. And we can just hook it back in. But I believe that we're going to probably wind up changing this compressor. If the customer, I put a call into the customer, I'm waiting for them to call me back. This is not even an R12 compressor. He told me it was an R12 compressor, and he told me that there was a restriction in the heat exchanger. All of that is not true. This is an R404A compressor, a Danfoss. I don't know what the horsepower is. I don't have any numbers on this model, SC12CLX.2. I have no specs on Danfoss compressors. But that's the model number. I'm sure I can find out what horsepower. But the thing is, it's an R404. So we're going to probably wind up changing the compressor. I have to wait for the customer to give me the okay. And then once we do that, we'll cut this out and weld those studs back onto place. All right, so that's where we're at right now. I'll get back to you. Okay, I talked to the people at Northland this morning, and I also talked to the owner, and the owner told me that this compressor was put in 2012. That's 11 years ago. But the people at Northland told me that there's nothing available in parts for this machine except the defrost heater, which we'll check before we, and the evaporator fan motor he said was available, but that's something that we could probably adapt something to, but that, I don't think that's bad. And also, the way this unit works, the cold air goes down. There's a cover here that goes on top of here. And then it blows the unit, the cold air, down through this channel down here. See if I can pick this up, because this thing is really heavy. You can see that channel down there, and it blows it down into the refrigerator section. All right, now, since the fan blade is not available, we're going to have to fix this one. It's a little bent out of shape. The bracket was bent out of shape. I'm not crazy about this fan motor. It's kind of looks a little tight to me. See how it abruptly stops? It doesn't really slow down. So that motor's going to have to be replaced. Now this is a foot mounted motor, and it's a clockwise. It's the same as a Sub-Zero. You can see a little dent where that compressor hit this thing. So obviously the shipper dropped it. Anyway, I have a fin comb here, and I'm starting to fix these fins. As you can see, try to smooth this out. It's really... Alright, so we're going to work on this. That's really smashed up. We're going to work on this, and then we're going to pull out this compressor and re-weld these studs on here. Now I have a Embraco 3rd horsepower R12 compressor, which is what this thing actually called for when it was made. Timers, we can replace this. These are kind of universal, just like the limit switches and the fan motors. So what we'll do now, I'm going to work on this first. I'm going to pull this compressor out. We're going to put this compressor in there. And also the people at Northland told me that since we don't have the connectors for these Molex connectors, he told me that the power in was, I believe, this one right here in the middle. He said these two. He said take a wire and jump between here and here and here and here, but there's no wire in the bottom. So that red wire, which is in the middle, comes out and goes to the compressor. This is a common, which is hooked up to this common terminal right there. Since he doesn't have a wiring diagram either. So we're going to have to figure out how to power this unit up so we can get it up and running, and then check the defrost heater, limit switch, and all the other things after we pull this out. Alright, so I will work on the condenser and change the fan motor, and then we'll start changing the compressor. Okay, here's an update. I removed the condenser and I cleaned it up a bit as best I could with a fin comb. So we can consider this done for now. Now here's another problem I came into. When I took off the insulation off the suction line heat exchanger, this is what I found. All these little cable ties holding the capillary tube on the suction line. You can feel underneath where all the solder is, so this thing was soldered on. And so the guy that owns this told me, he said the thing was running and cooling, but it wasn't cold enough. That's it right there. Heat exchanger is no good. So on a previous video I made on a Sub-Zero 22IM ice machine, I did a rebuild. I show you how you can repair this, and also on a Trolson that I did, I had to make a heat exchanger. So what we're going to do, I'm going to pull the compressor out and so I can get to the suction line, and we're going to clean this up, and we're going to resolder this capillary tube to the suction line, because that's the heat exchanger. Without that, it's not going to work properly. And then we're going to just clean it up. Now, this is the compressor that I have. It's a 1/3 horsepower R12. This is a 1/3 horsepower R404. I told you before, I pulled out 8 ounces of refrigerant. I don't know what refrigerant this is. What we're going to do is we're going to put a gauge on here, and we're going to detect the pressure, and that should tell us at room temperature what Freon is in here. All right, so let me just take out this one last. I got one more of these studs here that came loose. We're going to have to re-weld those on there, but I'm going to pull the compressor out, and the only thing that's holding it in right now is this suction line. All right, so let's do that next. Okay, so we got the compressor out, and another problem here. This is stainless steel. See, it's not magnetic. I'm not going to be able to weld that because I don't have any stainless steel welding rod. So either I'm going to have to pick some of that up so I can re-weld these on here, or drill holes in here and put this in from underneath like so, and a washer and a nut, and hope that that will work. So right now we only have 3 of these. I'm missing one, and I don't know if I have them. All right, so let's get back to work. Oh, here it is. So now I do have 4. So, okay, let's figure out how we're going to mount this compressor, and then we'll fix the suction line heat exchanger here. Okay, so I'm messing around with this, trying to figure out how we're going to make this work. I measured the height of the new compressor. It's 8.5 inches high. The old compressor's 8 3/4. So height-wise, we're okay. Also, the mounting studs that broke off were here and here. And if I put this compressor in a position where the old one was, then look what we have here. We have a problem. So we can either get a different compressor that has the ports in the front, or we can cheat this thing. Since we have to weld these studs back in, we can take the compressor and turn it and put the mounting studs in a place where we can get a little bit more room in the back, and we can put an elbow on the suction line and connect it in that way, and then the discharge line, we could make a 90-degree bend, but a long bend, so it doesn't create any extra friction, and then come out over here and into the condenser. Now, fortunately, everything comes apart. Like the condenser came off. This tray, the stainless steel tray, comes off to make it easier for me to weld. The problem I see here is this condenser fan motor bracket. Okay, mounted. Look how close it is to the compressor, but it will be held in place by the cover because all these screws in here will keep everything from moving. Excuse me. This is the thing I worry about right here. The clearance. It's really, really tight. So I'm going to put a new fan motor in here. I could fabricate something so that it's bolted to the bottom and not use this shroud, but we need that. So I'm just thinking out loud here what we're going to be able to do. So right now, this is the way I'm planning on putting this thing back together. And then the cover here, to make sure that everything is going to fit. These screw holes hold that condenser shroud there. These go in there like that, and it holds everything together nice and tight. And there's enough room in here to get to everything. So this will be our process port that we can check, and then we'll have another filter dryer with a process port on that right here. And so we'll be able to get to both the high side and the low side from the front. So the plan right now is I have to go to my welding supply tomorrow and pick up some stainless steel filler rod because I don't have any here. And then hopefully TIG weld these supports to this stainless steel pan in a position like that. It will hold the compressor in proper place. And we'll be able to get to the back. Let's see, yeah, we can get to the back, and then we'll just make some nice smooth elbows that will come up and go into the condenser from there and the suction line. So I see that as feasible. So that's the plan. But in the meantime, it's too late for me to go get the rod today I need for the welding. I'll do that tomorrow. But in the meantime, I just want to show you how this thing comes apart. That's the beauty of this unit. You can take it apart. Alright, so we got the condenser. We got the condenser fan motor, the bracket, and fan blade. And then we have the tray, which comes out also. Now there's a broken bolt over here, so what we'll do is we'll punch another hole into this tray, so we have 3 bolts that hold it in place. Right here it's broken in there, so we'll punch a hole in here and we'll drill a hole, so we have 3 ways to secure this thing. So now I'm going to clean this up. That's the project for the rest of the day. Clean this up, get it ready to be welded, and then we're going to fix this heat exchanger. Okay, we're back, and what we did here was we tack welded these studs to this stainless steel drain pan so that we could mount this compressor in a different location or a different position. That's going to go on like that. Now what I also did was I cut off, you can see I trimmed the corners off this mounting plate here so I can cheat it as far forward as I can, because I need as much room as I can to get this suction line, because don't forget the wall's right there. I'm going to put a bend around there and then come up into the suction line. So this came out well. We'll put this back together, hook it back into the cabinet, and proceed. Well, next thing we'll do is we'll start to map out our refrigerant lines, like the suction line, the discharge line, and all that. We can start putting things back together. But this was a critical part of this because I didn't have any stainless steel wire or welding rod, and I had to go pick it up this morning. So, all right, so that's where we're at right now, and let's move on. Okay, so now the tray is mounted, and I'm going to put some Mortite, some permagum here underneath here, because this is a drain pan. I don't want that water leaking out into the box. And it's not sticking very well. Okay, let's use some silicone. Okay. So now compressor's mounted. I'm not screwing it down yet because I may have to take this compressor out to get the tubing in there. So now I'm going to make a piece of tubing that's going to connect from the suction line and come around up into here. You still have to fix the heat exchanger, but I can do that when all this work is done. Okay, let's put a 180-degree bend on here. And we can just cut it as we need it. Figure that's going to go in there like that. Okay, so what we'll do, I'm going to cut this. Let's see if I have a piece of 5/16 tubing made in America. Okay, so here's a piece of tubing that I made up. This is 5/16. It's going to go in like that, and this, I swaged this out to 5/16, so this will fit in here. And then we can, once we sweat this in here, we can tweak it so that it's not in the way of the condenser fan motor. But so let's get this in here and set up, and then we'll work on the discharge line. Okay, here's an update. This is what we've been doing. We've mounted the condenser back on. We straightened out the fan blade because that was bent out of shape and it's not available anymore. The condenser fan motor is also not available anymore. This is a 1100 RPM, 120 volts, 60 cycles, single phase, clockwise rotation. It's very similar to the Sub-Zero motors, except the Sub-Zero motors, to get one that's foot mounted at 1100 RPM is, I can't find one. So what we're going to do is, I've got this brand new Whirlpool condenser fan motor right here, 833-697, and we're going to use this bracket. Now this bracket, I had these made up about 30 years ago when there was a shortage of condenser fan motors. Couldn't get them. So this is made out of 11 gauge aluminum angle, and this bolts on to the back of the motor like this, and then the 4 screws bolt in like that. So that will hold the motor in place. That's the only thing I have right now. This is 1200 RPM. It's pretty close to what we need. This should suffice. Okay, that's one thing. And then also what I did was I got all the tubing hooked up here. You can see the suction line, the discharge line. We got a little tweaking to do here. Filter dryer I put on. And right now I'm working on resoldering the capillary tube to the suction line, the heat exchanger. And I'm going to show you how I do that. It's very simple. Okay, so this is very simple. These are aluminum clothespins that I got on the internet. I believe I got these on eBay long time ago. They're great for act as a heat dissipator. So I just take a regular propane tank and get some lead solder or some kind of solder. Now I'm using this Stay Clean acid flux here with a little brush. So I'm going to heat it. We're going to put some flux on it, and then we're going to put the solder, and we're going to work our way around until up to this joint, which is about where it was before. And that should suffice. So I'm going to heat this suction line up a little bit here. Okay, I'm going to get my brush. And then we're going to get our solder. Okay, so that's basically it. I'm going to work our way around until we get to the end. Okay, so you will just move. Let me make sure these things aren't burning hot here. You're just going to move this here and then work your way around. And that's how we're going to do it. So let me finish that and I'll get back to you when we're done. Okay, we're just doing the final section here. You can see I got that capillary tube soldered on. All right, that's good enough. That's going to work much better than not being soldered on. Okay, now before I wrap this all up with insulation tape, I'm going to clean this tubing, clean any acid off from the solder so it doesn't cause any premature wear on this tubing here. These are great if you can find them. I had, I think, 8 of them. I gave some to my guys, and that's it. So we're going to use some citrus cleaner here. Clean this up. And that's about it for that part. So now we'll wrap it up. Well, wait, before we wrap it up, let's pressurize it first and check, because I'm going to have to make sure I check that joint, make sure it's not leaking. But everything else in here is looking pretty good. We're going to fix this, push this down a little bit so that's not rubbing. Okay, and then we're going to change the fan motor. Okay, we're going to remove this bracket. And we're going to use this little rubber. Always put these rubber washers on when you have a metal blade. Otherwise you might get this kind of noise that's annoying. Okay, now we got 1, 2. You know, you can look at my on my channel. I have a video on all the different fan motors that you can use on these refrigerators. I have a comparison chart somewhere, and it shows you the different speeds. This is going to go like this, so I'm going to change this so the wire's on this side. Different speeds and performance attributes of each motor. It's very helpful if you have to maybe replace a motor that's not a factory motor. Okay, so we'll put that like this. These were lifesavers back in the day when we made these brackets. Because like I said, we used to use the Robert Shaw condenser fan motors. They were the best at the time, other than the factory motor. And we bought them by the case. I think there were maybe 12, 18, something in the case. And then for some reason or other, Robert Shaw stopped making them. And there was a shortage. There was an actual shortage. And so, you know, necessity is the mother of invention, and this is how we compensate it. Now we use the factory motors mostly now, except on some units. Okay, so we got our bracket. Now we don't have to put the ground wire on here because this bracket is metal and it's bolted to the chassis, which is grounded. Otherwise they give you a ground wire right there and you should use it. There's a reason why they put it on there. Okay, so we got this all straightened out. Now we're going to remount this in here, like so. These are stainless steel screws, so they're not magnetic. Okay, that's free. This is going to get screwed into the cover, and that'll support this. Like that, so it doesn't vibrate. There's not very much of a pitch on this blade, so I don't see how much air it's going to draw through there, but that's the way it was designed, and that's what we're going to do. So these wires will get hooked into these wires and onto the relay. So now that we have that mounted, the next thing we're going to do is we're going to charge it up with nitrogen and check for leaks. Okay, let's charge her up with nitrogen. Let's let that balance out. I'm going to close off the gauges. Okie dokie. Let's check our joints. See how well we did. Check them all, even the ones you didn't solder. You never know, as this thing's going back upstate New York. I don't want anybody to have any problems. That looks all good, so let's check. Let's check the ones in the back here. I want to say it's looking good. All right. We'll pull a vacuum on this before we charge it up. And by the way, I mentioned before that we didn't know what refrigerant was in this column. And unfortunately, it's leaked out, because when I first put the gauge on, there was about 102 pounds PSI, and we pulled out 8 ounces out of the system, and right now it's only showing the 1. But I looked up on a pressure temperature chart, and I measured the temperature of the charging column, which was 66 degrees, and so 102 PSI indicated to me that they were using R417A hotshot. So unfortunately, I must have a leak in my gauge. That stuff does happen. There's still pressure in there, but the freon's leaking out. I know I had a little slight leak here, but I got a cap on it. So anyway, we're going to charge this up with 134A. This compressor uses poly oil, so you can use 12 or 134A. There's one more joint I didn't check. Right there. Okay. That's it for now for this part. So we have to do the wiring next, but let me get some insulation tape and clean this all up. And we'll wire up the compressor, we'll pull a vacuum, and dry out the system. A couple of other things I have to check while it's here in the shop is I want to make sure the defrost heater is working. Looks like somebody did some work on this before. Here's the limit switch. This brown wire, there's a yellow wire here. This goes to your defrost heater, and it's coming out of your terminator switch there. So I know the evaporator fan works because I plugged it in and jumped out the system. I know that works. So we're getting there. We're almost done. All right, let's get on to the next thing. Okay, here's we go. This is insulation tape. I'm going to stick this onto the suction heat exchanger and wrap this whole heat exchanger in insulation tape up to here. Okay, that's all that's necessary. If it gets moist, sometimes that happens when you have a little bit of an overcharge. You might get a little bit of coolness or frost on the line, and it gradually goes away as the compressor picks up speed. That's okay, but that moisture, because it's exposed to the air, will evaporate. It's the you want to keep the moisture out from in here so it doesn't corrode the tubing. And this is copper tubing can corrode. So let's, and by the way, This is the pressure in the system. I went in and had lunch, came back out. It's been over an hour and the pressure has not moved. So I'm very happy with that. So the next thing, finish the installation. We'll check the heater and we'll put the cover back on and pull a vacuum and charge it up and get it running. Okay, so this is how I coat this heat exchanger. I use this black insulation tape. It's right here, Armaflex. And one of the reasons why I cleaned this before with that citrus cleaner is to get all the residue off here and make this dry so that this insulation tape would stick. And it's sticking very well. I'm very happy with that. So now I put it on an angle. Pull it through, stretch it a little bit, like that. Keep the paper under there so it doesn't get stuck. And pull that out, twist it a little bit, and bring it around like that. Okay, so these two yellow wires right here are wired into this termination switch. It's also called a limit switch. And what this does is when this unit goes into a defrost, this heater comes on. If this thing wasn't here, or if it was not working, it would cook the food. Believe me, I've seen it. So this is a safety, kind of a safety switch. It's a limit. It limits how much hot it can be. And some of the newer refrigerators today have the evaporator fans wired through the limit switch, so that when the unit comes back on to cool, that fan will not come on until the coil cools, so it doesn't circulate hot air. Kind of a cool and more efficient way of doing things. Anyway, here's the two yellow wires. One, this is for the heater, and the other wire for the heater is right here. So let me figure this out, and we will get my amp probe, and then we'll check and see if the heater works. Okay, got our amp probe. Now we just have to figure out how we're going to check that defrost heater. I just wanted to point out that this blue and white wire right here goes to the evaporator fan motor. So you can see the wires coming out from there. Here's the blue wire, and the blue wire comes in here and goes down to here and attaches to this red wire, which comes from which is attached to the same middle pin. You see I have it jumped out, these two. Now these are the people at Northland told me to jump all three of these out to get everything running, but I think this bottom hole here is for an ice maker, and this doesn't have an ice maker in it. We don't have any wiring diagrams. There's no service manuals for this unit, so we're just making it up as we go. But anyway, that's the fan motor. And so the defrost heater, which is down here, goes out, comes back up, and comes out under there. And then it's wired in series with the limit switch. So that wire is right here. It's attached to all these common, this is like a common terminal right here. There's a black one terminal down here with all black wires. These are the white. Normally white is normally ground or common. Green is actually ground, but this is common on alternating current. So we just need to jump between here, this terminal, at least not jump it, but apply power to those two black wires, and that heater should come on, and then we can measure the amperage and see if the heater's good. Okay, I rigged up a jumper cord, which I got from an old appliance, and made this jumper cord. And this is your defrost heater, and I put a junction here so I could plug this back in. So I'm running this heater direct, and I'm going to plug it in, and I'm going to check the amperage draw. It's drawing 4.4 14, 13, over 4 amps. That's a heavy heater. Just gonna wait for that to, and it's not wired through the limit switch because the limit switch is open. It wouldn't fire it up. That's why I had to splice this lead wire here. I hear the aluminum tubing expanding. 4.10. See the smoke? I don't know if you can see the smoke. There's steam coming up out of there, smoke. I want to make sure it's not burning or anything. No. There's a stainless steel pan underneath this evaporator coil, just like this stainless steel pan that holds the compressor. That's a drain pan. And I'll wait for that to get hot to make sure it's working. Now, when I spoke to Northland, they told me they had a defrost heater, and I think he said he had the evaporator and the evaporator fan motor and the limit switch. He did not have the compressor, did not have the condenser fan motor, did not have the blade, the condenser, or anything else. Now this timer also is kind of strange because my 57 years, I don't think I've ever seen an adjustable, this is a Supco timer, an adjustable timer where you could adjust not only how long it stays on a defrost, but if you wanted to do every 4 hours, 6, 8, 10, 12 hours. So I'm going to put a new timer in here, but I'm not going to put an adjustable one. I'm going to use a 10-hour timer with about a 20 to 25 minute time period for the defrost. It's what we use on the Sub-Zeros. Okay, this is getting warm. I can feel it. We can get a temperature gauge, a temperature monitor here. See, it's going up. 91, 92. So it's getting hotter. The coils are warmer, but the fins. And I go down by the heater. Where is that heater? Oh, there it is. Right there. 13, 246, 143. So yeah, that heater is working, and that's good news. Okay, let's fix this back up and get on to the next part. Okay, so now we're going to wire up the compressor. Let me get my necessary tools. Okay, so here's how we're going to do this. These are your two wires coming from your control center here. One red, one white. These are going to go into the relay and the overload like this. I'm going to change these terminals, but it's going to go on like this. And then we're going to attach these two terminal wires that will attach to each one of these like this, so that they both get power at the same time. So whenever the compressor's on, the condenser fan motor is going to run. So we're going to, I could just splice into these and do it that way. I don't like these terminals. They look a little sloppy to me. So let's do something better. Okay, so we attach these new terminals to the relay here, and then we have to hook up the cover. Okay, so here's the cover that goes over and protects the relay. These wires are going to come through the side here like this. We have to bend them, get them in there, because this overload has to sit into that opening right there. So let's do that first and then try to do the wires. Okay, that's good there, that's good there. Everything's bolted down. We still have the same amount of pressure. Let's see, the problem putting a new timer in here is this thing going to only have one bolt to hold that in. Okay, let me get a new timer. Okay, this is a General Electric WR9X483. I've been using these along with the Sub-Zero timers for, I don't know, 20, 30, 40 years. They've changed shape a little bit, but they've always been reliable. And that's it. On this one here, you have an adjusting knob, so you can put it into a defrost. You'll hear a click. Right there, that's defrost. That sends the power from the center terminal to the outer terminal, which is the defrost terminal. This is the compressor. So the power coming in here, this is a common. So this is just a push on, pull off, same setup. And that's going to sit just like that. Okay, so there's the timer. We reattached connected the defrost heater wire there. Okay, that's all set. Now I think the next thing we need to do is we need to put a little permagum on here just to seal it up a little better, make it as airtight as we can get it. Okie dokie. This cover here goes on like this. And then this cover here, which is insulation, 2 inches thick, goes into here. Like this. So let's get all these bolts here lined up, screwed in, and then we'll start working on the sealed system again. Okay, let's empty the nitrogen. Okay, it's up and running. I got the high side open. I'm doing a sweep charge. It looks like we're into like a 29-inch vacuum. Perfect, beautiful. So let's let this run for a little bit and suck out any air. We'll disconnect the discharge line, and then we'll weigh in 8 ounces of our 134A, and then we'll test it. Now, with this condensing unit, the air that is blowing out the bottom from the evaporator is blowing it down because it goes down into the refrigerator cabinet. So when we test this thing, we have to bring it up off the bench so that the air can escape. Then we'll measure the air temperature and see how it's producing. Okay, we got this thing back together. Got it up on blocks, 4-inch blocks. Underneath there is air goes in from the cabinet through the evaporator coil and back down into the cabinet. So we need a way for that air to circulate there, otherwise we're going to get false readings. I am going to weigh in up to 8 ounces of refrigerant 134A. But before I do that, I just want to turn it on and see if make sure there's no air in the system. And I'm going to do that by just letting the compressor suck out the air, and we're just going to purge the filter here. And nothing coming out of there because I already was in the vacuum, but I just wanted to make sure. Okay, so we'll put this back on. Alright, so I put the cap on there. I just want to purge some air out of the hose. Make sure we don't get any air in there. I mean, just to be safe, we'll shoot some Freon in there, and then we'll purge this one more time, just to make sure we can pushing out any air that might be in there. Yeah, I heard a little bit. Okay, so now it's completely clear, and we just have to get some Freon in there. And instead of weighing the gas in with the charging column, I'm going to use the scale and check the pressures at the same time to see that maybe we don't have to put 8 ounces of a 134A in there. So we'll see. Well, it would help to turn on the scale. So let's turn on the scale. It's on pounds. We want it to be on ounces. So it's 526.8 ounces in that tank. Okay, let me just purge this one more time. Okay, here we go. We got 527.2. 527.2. That's how much the tank weighs. We want to get 8 ounces in there. Or at least we'll check our head pressure and our suction pressures. Right now I can only hear the fan running. I don't even hear the compressor. It's so quiet. Okay, so let's let this run for a while and then we'll come back and check it. Okay, so we got this thing all buttoned up. It's ready to go, but we have to just do some final testing. I've shut it off for a couple days to make sure it's not leaking. the pressures are balanced out. I'm going to put it on, we're going to turn it on, and we're going to check the pressures. And then I'm going to pull all the Freon out to see how much Freon I put in there, because I wasn't sure on the exact charge. So let's turn it on and let it run. Now I put these 4x4 blocks around here to block the cold air, because the way this works is the cold air gets drawn in from the bottom, goes through the evaporator coil, goes back down, and goes back into the cabinet. So by putting these blocks here, it kind of holds the temperature and allows the system to pull down. So right now we're just turning it on. We got 20 pounds back pressure. It's going to go down as it starts to cool. The head pressure is at 160 right now. And so like I said, we charge this up with 134A. We're just going to verify the pressures, because since I don't have the box here, the cabinet, I'm not going to be able to do any final testing. I'll have to charge it up by superheat and amperage draw. And just to do a recap, this is the old compressor that came out. This is a 1/2 horsepower Danfoss. It's an R404 507 compressor. It's a little too strong for this machine. I have never seen a domestic refrigerator or residential refrigerator stronger than the 1/3 horsepower. And that's what we put in, 1/3 horsepower, 134A. So since we did a conversion with the refrigerant, I wasn't really sure on the exact amount of Freon. Although the Northland serial tag here says 1/3 horsepower, 8 ounces of R12. And I think I put in 12.6 ounces, but I've been playing with the Freon chart. So now you're down to about 1 pound back pressure, which is kind of normal for 134A for a freezer temp. And it's okay if it runs into a little bit of a vacuum, as long as it's we don't have any high head pressures here. So the head pressure is kind of normal also. Right now the ambient temperature in here is about 70 degrees, 65 to 70 degrees. So that's about a normal head pressure for this temp. So I'm going to let this run for a while, and then we're going to package it back up and put it in the crate and send it off to the customer. Okay, any questions, feel free to drop me a line or respond on my YouTube channel, whatever is convenient for you. Thanks for watching. Hope you learned something. Okay, one more thing I want to mention is I'll take a pressure reading of the tank. It's 60 psi, and the temperature in here is about 65 degrees. 65 degrees is 60 on 134A is 64.1 psi. It's pretty close. It's a little low, but that's what it's telling me. So normally what I was taught in school was you add 30 to 35 degrees for heat of compression to that temperature, and that's going to bring us up to 95 to 100. So the head pressure should be around 124, and it's pretty much in that range, 124. It's running in a vacuum. That's okay. It's 134A. They do run in a low vacuum sometimes. I can feel the suction line. I'm happy with that feel because it feels okay. All right, that's it. See you later. Okay, it's drawing 4.12, 11, 10 amps. That's also with the condenser fan motor. So the amperage draw is in the right range. The pressure is in the right range. It just kicked into a defrost, and I took it out of a defrost cycle, so we know that's working. So everything to me is looking pretty good. And as the temperature drops, now the heater came on, and so it got a little warm in there, and that's why the pressure is up a little bit. But as it cools down, the pressure will come down. So I can feel the cold air underneath there. So it's coming out, it's going right back in. If I block the intake, the pressure will come down even more. Okay. Also, one more thing. This has been my Bible for the past 50 years, this book. If you don't have one, it would be great to have it because it covers pretty much everything. Now, this is the 18th edition. The original book I bought, I don't even remember what edition it was, but it was about 50 years ago, and somebody stole it from my truck, and so I bought this one. Great book. All right, I'll get back. Okay, this Northland unit is packed up and ready to go back to the customer. So thanks for watching. Any questions, feel free to reach out to me. Thanks a lot. Thanks for watching. Bye.